Thanks, everyone. Can you hear me all right? All right, that sounds good. So we're going to talk about how we can use AI and machine learning to power our images while we're building apps or websites. I'm Doug. I was here last year, so I see a bunch of familiar faces. It's good to see you all again. I'm a digital nomad traveling around Europe with my family. I'm originally from Seattle. And I do freelance developer relations, and I got started in all this doing performance. How can we speed up native apps? How can we speed up mobile apps or websites? I wrote a book on how to speed up Android apps. That's the PDF if you want to download it. I'll post the slides on Twitter later, so you don't have to copy down that URL. I do a lot of stuff helping companies speed up their websites, and that got me interested in like how can we use AI and machine learning to help us do this automatically, right? There are a lot of these steps that are very manual processes, and we want to speed them up. If you ever want to reach out to me, I'm the only Doug Sillars on the internet. I'm pretty easy to find. When we think about how we build interfaces, whether I'm going to show the web here, but the same talks about for native apps. These are 10,000 random websites I pulled off out of the HTTP archive, and as you can see, like, most of the data that's being downloaded on every web page is images. Most of them are over 50%, right? Images make a huge amount of the tonnage on web pages and native apps. If we can make those images optimized and make them smaller, they're going to download faster. And if they download faster, it makes your app faster. When your app is faster, people use your app more often, they use your website more often, and actually if it's an e-commerce site, they buy more things, which is, if you're building a site to sell things, that's a good thing. So how do we get images out for the web or for an app? Like, we always like to think that somebody out there taking photos for us that you can then optimize. Most of the time it's we're doing a Google image search to find the images that we want. The next step after we collect all of those photos is we open up Photoshop and we start manipulating the images so that they look great for the right, for the orientation of the device, for the size of the device. We have to do some manual labor here to optimize the images. And then finally, it goes up onto our website or into our app. And I talk a lot about how to optimize the stuff when it's being delivered onto the web page, and that was the talk I gave last year. But what about here? This is a very time-consuming and manual step of getting the images ready to go to production. And what I see is that there are a lot of people taking shortcuts, and when they do these shortcuts, the images are not necessarily optimized to the best for the customers. Here's a comment from Twitter from earlier this year: taking a screenshot is not a good way to serve a photo on the web. And you may all be laughing like, haha, yeah, who does that? This is from DevTools. And if you use a Mac, you may recognize the format of this image: screen_shot _year -month -day time, etc., etc. So this is a website that they got the optimized image on their computer, and then rather than saving it, they took a screenshot and then they just pushed it live. And screenshots are awesome. This is a screenshot of a tweet that I did, right? That's great, but they're not optimized. You have to do some work to make sure these images look great. So I went through the HTTP archive, which is like 5 million websites, and I said, how many images out there have the word screenshot in it? And there's mostly PNGs, because that's what Apple saves them in. There are a bunch of JPEGs. I don't really know what a PHP image is, but whatever, we'll go with it. But there's 426,000 of these on the web as of earlier this year on 100,000 websites, which is 2% of the web is using screenshots live in production. And that seems like a lot. We can be doing better than that. I went through and I grabbed 3,000 of them and I just did some optimizations. I turned them to a JPEG. I applied a quality improvement to them. And you can see that 86% of them got to be 50% the original size, and 35% of them are 10% the original size. So if the images are smaller, that means they're going to download faster. If they download faster, people will use your app more often. So this shortcut of taking a screenshot can have a lasting effect and does affect your customers. So we should think about this. Taking a screenshot is fine. Just make sure that you're optimizing the image before you're pushing it live to production. So let's talk about some other shortcuts that are out there. This is a picture I took of me, and I want to crop this into a square. There are a lot of tools that will do this. In this case, I'm using Cloudinary. It's a cloud-based tool. And you upload the full image, and then you add parameters to the URL. And so I'm doing a center crop, height 1,000, width 1,000, and it gives me this image, right? I've got a way now to crop images in a way automatically, and that's going to be awesome. The second two parameters here is I'm optimizing for quality and optimizing for format. So what it'll do is it will realize what kind of device, what kind of browser is downloading it, and serve the optimized format. So like Chrome may get a WebP, where Safari will get a JPEG 2000, because they support different image formats that have different compression capabilities. So we're at 120K. I'm happy with that, just by adding a couple parameters to the URL, which is super fun and easy. But what happens when I use this image? Right? Center crop, not so good, right? We're not, this isn't going to work for us. This process, my fix only works for specific, photos. So, a manual crop isn't a shortcut. So what we can do is we can use some AI. And so a lot of these tools now have AI to find the most important part of the image. And in this case, it's called G-Auto, the gravity auto. And luckily, this AI thinks that my face is one of the most important parts of the picture. But you can see it frames it nicely with the Swiss flag, and it's actually a really nice photo. So again, then I'm just cropping it 1,000 by 1,000. And so now we've got something that will detect the most important object and crop it and give you a nice looking image. So these are available in a lot of different tool sets, and it will give you, it will find the most important object. This is live on Twitter today. So as part of our traveling, we get to go to lots of cool places, and my son is obsessed with World War II history. We were in Poland, and so we went to go see Hitler's bunker. And so this is the remains of Hitler's bunker. It is really a one-story building. It just has 15 meters of reinforced concrete on top of it, because he was worried about, obviously, people bombing him. So I was like, I'm going to post this on Twitter, and Twitter actually finds the most interesting part of the image. In this case, the door, not the 15 meters of moldering concrete. And it centered it and found that, and it works really, really well. I did see an example of where a friend of mine went to the Taj Mahal, and the Twitter API focuses on people over objects, so it focused on all the people and skipped the seventh wonder of the world at the top of his photo. But in general, it works really well, and that's kind of cool. This is sort of machine learning AI image cropping in production being used today, which is fun. So how can we do object detection? Let's do an example. This is the image AI library, and if you just Google image AI medium, you'll find a tutorial that will walk you through this. It's TensorFlow based, and you give it an image model library. In this case, I'm using the ResNet 50 library. You write a little bit of Python. And what does it do? This is an image of a town in northern England. I ran it through the system, and what was really cool is it finds a lot of the objects in the image, and it actually found stuff that I didn't even notice were in the image. So these are all the things that it found. It found a bunch of cars, it found the bus in the middle. The thing I didn't notice is it found the clock on the church or the city hall at the top of the screen. I didn't realize there was a clock until I was looking through what it found. And so you can see clock, it's 54% sure that it found a clock. I don't really get why it has like 16 digits. Like, there's no way it's that accurate. I'm into sig figs. I'm kind of a nerd that way. That's way too many sig figs. But then on the right there, it gives you a box. Those are the XY of a box surrounding the pixels where the clock is. You can see it's 84% sure there's a bus, and indeed there is a bus in the middle there. It's really sure about a bunch of these cars, like 99, 98, 98. It's not so sure about two of them, and that's because they're not cars, right? It's seeing this that right there, and there's a sign back there that it thinks is a car. It's finding a lot of the people that are discrete people, like they're separated. Over here, they're all kind of jumbled up. It didn't find any of those people, right? This is still pretty cool. Like, it's finding a lot of the things in there, and it was really just like a template that I put into Python, and it did all the work for me, which is really kind of neat. So, what can we do? We can do this sort of cropping, identify an object and crop around the image. So you could imagine if I wanted to crop around the bus, I know exactly where the bus is. I've got XY coordinates for a box. I could crop this image around the bus or around the clock or around the people. So there's a lot of fun things we can do just with this library. Google Maps uses this to identify like license plates, and they blur them out because they want to keep that sort of personalized information anonymous. And they'll do it with signs and like numbers on doors and things as well. So they'll identify something and blur it out. This is in Munich, and they got a bunch of photos of this square in Munich, and they were able to remove the person standing there, except for his feet. Because they couldn't get the cobblestones around his feet enough to make it go away. So, I think that's really funny. But it's in Google Maps. If you're interested, that's where it is. You can also do AltText creation. So this is a picture of me with a couple of llamas, as one does take a selfie with a bunch of llamas. And I ran it through one of these tools, and the AltText would be a person and 2 dogs. So this goes back to these models are great as long as they've been trained to identify the things you're looking for. And so in this case, this model doesn't know what a llama is, and so it just found what it thought they were, and it decided they were dogs. And it's actually really, really sure that they're dogs. This is one of these things use these tools. They're really awesome, but you also have to use a little bit of caution with them because they can screw things up to sort of, in this case, in humorous ways, but there's a lot of information out there about ethics in machine learning where you can actually really screw things up for a lot of people if you don't do it right. Like here, I'm playing with llamas and dogs. Hopefully I'm not hurting anyone's feelings here. However, there are libraries that do know about llamas, and in fact, there's a PWA at llama.vision. And if you load this up on your phone and you hold it up to my slides, it will find the llama because it has been trained, that model has been trained to identify llamas. It's fun stuff. This is just fun and silly, and we're having fun with it. This is actually used in production now. People are actually using machine learning to generate alt text for images, and Facebook is doing this. So this is an image my friend posted on Facebook just yesterday or the other day, and you can actually see the alt text says, image may contain bridge, sky, tree, outdoor, water, and nature. It's not really describing the picture, it's kind of just listing the stuff that's in the image. To me, that's not great alt text, but at least it's giving, if someone was unable to see the image, they would have an idea of what they're seeing here. Image may contain dog, right? It got one of them, I guess. It doesn't really tell you what's happening in the image, just that there's a dog in the picture. My friend who posted this had this long description, and that description is probably there for people to read. Hey, one of the dogs actually took a nap for a second or something. I don't remember what she said, but right. This is stuff that is starting to show up in production now. There's always this disclaimer that image may contain, but if you use a screen reader, it'll actually say image may contain a dog, and that's kind of neat. So what happens, let's go back to the llamas, you can use a different model, you can do a different library that may have llamas in it, but what if you you want to train your own model? And this is sort of complicated, but it really is actually really easy to do once you figure out how to do it. And so I'm going to walk through the steps so you can see how easy it is once you figure it out. So I was doing this ropes climbing course, and I was up there taking photos, and I managed to get my thumb over my smartphone thing, and I was like, I'm going to have to crop that out so I can post that later. And I was like, but maybe I could use machine learning to identify my thumb and then remove it automatically. Pretty straightforward model, simple model to do. So object detection with machine learning. Who sees a rabbit? About half. Who sees a duck? We're a duck audience here. This is a duck audience. And so there are these tools that will do object detection. So it's identifying the llamas, it's identifying a person, it's identifying. So somebody actually ran this through Google's object detection machine learning algorithm, and they tweeted it. So we're just going to watch this video. And so what this is doing here, I'll go full screen here, is at every angle, is it a duck? That's duck. And then it switches. I've got to start the video over again. See if it's Sometimes I just have to, oh, come on. When in doubt, reload the page, right? Now it's not going to even load. All right, so here we go. Really sure that it's a rabbit. Rabbit here. And as it flips around, it starts seeing duck, right? So there's some, it's actually, the object detection can't really tell. Like there's that one area right there where it's both rabbit and duck. But for the most part, it's either rabbit or it's duck, which is kind of funny. I think this is really cool. The other thing that it finds, I actually went through the raw data, is it finds like this. It sees like a hand gesture of people saying peace out. I think that's really cool. So let's see what we can do to train with a library to find my finger in a bunch of photos. So the first thing I need to do is take a bunch of photos with my finger over the lens, right? So this is Max the dog with my finger over the lens. I downloaded a bunch of pictures off the internet where people were doing this, right? And then what you do is when you're doing these object detection things, you have to give all of the images and then also boundaries of where the object is that you want to detect. And what's neat about the Google object detection model is you can upload the images and like an XML file or a JSON file with all the XY coordinates, but you can also just upload all the images and then just draw it in the browser, right? So I can just draw a box around the image and say that's where the finger is. And so I didn't have to do those two. I could do it all in one step. I could upload the images and then just, identify where everything was right in the browser. And then what you do is you go through, it has a bunch of images where you've identified the thing you're trying to identify. You train the model. This takes a while. The more images you have, the longer it takes. The more complicated the model is, the longer it takes. This was like, you can see I have 43 images. And then it splits everything into a test set and the evaluation set. And you can see here is I had 6 images in my test set because it was wrong 1/6 of the time, both in precision and recall. So this is pretty good. This is my first try at building something. Obviously, when you're trying to identify a cat, you have to get every single pose of a cat, right? A cat in the sink, a cat in a box, a cat lying down, a cat on the stairs, everything a cat does. Dogs, you have to worry about all the different breeds of dogs to identify dogs. Like, it's very complicated. I'm just looking for a dark, a oval-shaped object. So it was pretty straightforward. And you can see I got pretty good precision, 95%, false positive 1 out of 6 times. Like, I'm pretty happy with this. So I deploy this model and I use it. And so you deploy the model up in the Google Cloud, you write a little bit of Python. Actually, the hardest part I had with this, walking through it, was to get all of my credentials working with Google, to be honest with you. Everything else was pretty straightforward. And I get a response back where it says, we found a finger, we're 99% sure, and here are the XY coordinates of the bounding box. Like, that's super awesome, that's super cool. I can draw with the Python libraries that I was using, I can draw the box around the finger. And then I can start doing things like, what do I want to do? I could crop it out, so I can decide whether I want to crop the image vertically or horizontally. And lo and behold, automatically I can generate this image sort of on the back end on the fly. And that's super cool, right? Now you've got a service that removes oops, I put my finger over the lens when I took a photograph. That's kind of cool. I wanted to go a little further. Has anyone heard of in-painting? Nobody. All right. So in-painting is the idea where you can use math to draw over it and sort of like try to clone the area around it so that you can keep the rest of the image there, and it just tries to draw over it. The stuff that's available in Python isn't all that great, unfortunately. There's 2 methods. There's the smeary method and the blurry method. There's the smeary method. So it's basically just taking the pixels on the end and just running it across, right? And then the blurry method is kind of the same, but it's just blurry. So they're not very good. There's a lot of work being done on this right now to do in-painting on the fly. So you can imagine this would all get cloned. It would identify that those should be bushes or something behind there and make it look more like a bush. It works really, really well on single color areas. So like if it's a sky and it's all just blue, it'll just remove all that blue. It's awesome. It's really, really bad at areas where there are a lot of colors. So I was playing around with this, seeing if I could do this better, and I was trying to do some tricks by removing the outlier colors, like the buildings, basically, and then do the in-painting. So I turned everything gray, so I only had to deal with 256 colors. I bucketed all the colors with some k-means, so just math, which colors are more common, which one are less common. And then, so that's all that is. And then I found the most common gray colors and how often they appear. And then, I just loop through all the colors, and if they're outside of the 50% in the middle, I remove them. And you can see I got rid of a lot of the colors there. And so when I do the in-painting, it's not perfect. Like, I still have some work here to do on my method when I get some more free time. But like you can see, like, we're improving the way the in-painting works. It's definitely a lot better than the first try that came out of the default libraries in Python. So like, this is still a work in progress. I'm still playing with it. But it's kind of fun. We can see that we can actually remove objects from the images in a way that, in a smart way. And while I was playing with this, I was interacting with some folks on Twitter, just as we do, and a guy was talking about he had a website, and when you try on sunglasses, you want to see what they look like on your face, right? And when you're buying sunglasses on the web, you can't do that, and so he wanted to build a try-on sort of tool on the web where you upload a photo of yourself, and it just puts the sunglasses on your face so you can see what they look like. And I'm like, well, that's kind of cool, right? It would look something like that when we were done. So the way traditionally this would have been done is you would have hired an intern, and you would have said, here's your laptop and here's Photoshop, and we'll see you in 3 months. But let's see if we can do this with some of the tools that we've talked about so far today. The first thing I did was, that's not going to work. It's a JPEG. It has a background, right? Obviously, we need to get rid of the arms of the glasses as well. We want to go more to there. So the first thing we did was to remove the background of on the sunglasses image. There are a lot of tools to do that. There's like remove.bg. There's an API out there that'll just do it for you. I'm familiar with Cloudinary. I used their tool. There are a lot of tools out there that will do this. So I upload the image to Cloudinary, and I say, just remove the background. And when I do that, I get an image that looks like that. So what I can then do is overlay that image on my face. I can make it transparent, and I can make it 30% transparent, 70% opaque, so you can sort of see my eyes peeking through there. The other thing I did was to make it transparent as I turned it into a PNG from a JPEG, because JPEGs don't have a transparency. They don't have an alpha channel to make it transparent. We still have the arms, so we're going to get to that. So train a model, right? Just like the sunglass or the finger model that I did earlier. I upload a bunch of images to the object detection model at Google, and then I train the model to identify different parts of the arms of the glasses. And you might be saying, well, Doug, you picked 3 for each one of these. Isn't that a pain in the butt? And it was really, really slow to do all of this identifying. The reason I didn't do just one is, remember, the in-painting does all sorts of weird smearing things. And so if I grab the frame, it just looks really bad. So I didn't want to do that. The best way to do that was to just do a series of boxes that sort of stayed wholly inside the lens of the sunglasses. It would be even better if I could use circles or ellipses, right? So that I could just grab the shape. Currently, it only lets you do rectangles. So I was stuck with rectangles, hence the 3. So I sort of did the temple, the arm, and then also the tip of the sunglasses. And so it looks like that. So I downloaded like 45 sunglasses. I uploaded them to Google Cloud. And then I carefully drew these boxes. And the first time I trained the model, it didn't do very well, because by about the 20th pair of sunglasses, I was like, and I wasn't super careful or accurate at how I drew the bounding boxes. And then I trained the model, and that was reflected in how well that model worked. So even though this is really tedious and a pain in the butt, this is the part that's really important. good data in means good data out from the model. So by taking the time and really making sure that I grabbed as little of the frame as possible on both sides there and really making sure I got good overlap there really, really helped a lot in training the model. So then you train the model, and when you have a bunch of images and you do this object detection model at Google Cloud, you can use, when you're training the model, you can set it to one node at Google to do the work, or many, many nodes. I picked one node. It took about 3 or 4 hours. The reason I picked one node is it's free. You can do multiple nodes, and they'll charge you per hour for each of those nodes running. So what happens is I get this image. I send it up to Google, and Google identifies the object detection model identifies the 6 regions of where the size of the glasses are. If there's an odd number, it doesn't work. And so Ray-Bans are really bad because this little logo screws up the object detection right here in the corner. It can't find that little bit. So the Ray-Bans never really work with my model. This one, you can see it didn't find the arm on the other side just because it's a different shape. But again, it will help remove a lot of the content, and then you just have to touch up the rest of it with Photoshop. So the next thing I do is I remove that area and I modify the border a little bit. So I'm doing that in-painting trick that I was just doing a little bit ago. And that way, when it does the in-painting, it will just smear in the colors from around this box, this sort of strange box that I've created. And what happens is you do the in-painting and you get something that looks like this. And at this big expanded scale, it sort of looks like my sunglasses after my toddler has been eating a bag of potato chips and then like all over the lenses. Through the magic of making the image smaller, that mostly disappears. But if you wanted to clear that up, we could do a little bit of post-processing to make that a little bit nicer. So now we can put all of this together. So your customer is going to upload a photo of themselves to put sunglasses on. Now you'd imagine that a customer would just take a picture of them, but they may take a picture where their face is over in the corner, right? And you have to make sure that your tools account for that. So here's this picture of me. I do, again, that cropping where I actually use, there's a gravity face as opposed to gravity auto, so it looks for the face. And I make it 1500 by 1500. So I upload a photo, and I now automatically crop around my face. That's super cool. Then I grab a pair of sunglasses, and I remove the background on the upload. And then once the background is removed, I send that off to Google. It identifies the space, where the arms are. I use Python to remove that, and then I upload it to Cloudinary, and I give it a label, and I make it transparent. And then what I can do is I can apply these 2 layers over one another. And so again, I'm just going to do this in the cloud. You could do this any way you want to. In this case, I apply a layer. So I add this layer of the sunglasses, and I apply it over the eyes. So they have an AI where it finds the eyes on the face. It applies that layer right over the eyes. And so there I am with these silly looking sunglasses on. But it works, and that's pretty cool. That's pretty exciting. And so now we can do a live demo. Here's a pair of sunglasses. There's the picture of me. And then we just do this all in Python. So what I have here is I'm just using Python to call the glasses.python. The first image is the picture of me. The second URL is the pair of sunglasses. I hit go, and it now does all of that work while we're just sitting here. Here's the URL to the final image. It only found 5 of them. You can see it only found 5 objects. So it's probably not going to be the best looking final image. But let's see. You can see it missed some of the arm over here on the side, right? Not perfect, but again, it's sort of getting you on the way, right? If you see that it's an odd number, you know that these are one of the 20% you're going to have to post-process. But let's get one that actually works. So this website is just one of these things where you just change the number and you get a different pair of sunglasses. Oh, those are going to be fabulous. And you wouldn't process the sunglasses you would process all of the sunglasses, have them all locally, on your server, and then do the overlay. In this case, I'm actually processing the sunglasses in real time while I'm building it, which is obviously a little slower, probably not the way you'd want to do it. So this one found 2. Let's see how good that works. Not bad. You can see actually when it removed the background, it actually removed a little bit of the lens there too. Work in progress. Like as a first run at this, it's actually working pretty well. Let's find one that actually works. These sunglasses aren't super ideal. It doesn't look like. That doesn't even. They're not even over the. That one's just going to work because I think they'll look fine. Let's try that one. Oh, yeah. And so the URL is being built ahead of time because, it's all parameterized. I know what it's going to look, what the URL will look like. Oh, so it found 6. That's good. Yeah, they're a little big. I think it made those sunglasses a little big, like they're too big on my face. But, you get the idea. Like, I think a tool like this with a little bit of tweaking, obviously, you could make this a tool that you could put on a sunglasses website, and it would really help people decide whether these are the sunglasses they want to buy or if they're sunglasses they don't want to buy. In conclusion, we can do this image processing with AI and machine learning, and it can really help us optimize the way we build images for the web or for our apps. We can do automatic cropping, we can blur things, we can remove objects, we can generate the alt text, and we can do this all automatically. Obviously, there should be probably a little bit of a review before some of this stuff goes live, but if we can remove 80% of the hard work, so we just have to do 20% of the tedious work, I think that's a huge improvement on sort of the grunt work that happens while we're building content to go up on the web or in our apps. So thank you. If you're interested in some of these tools, we can talk about the Media Developer Expert Program at Cloudinary. They help with a lot of that. And I'm here for the rest of the day, so if you have any questions, I'd be happy to talk with you about them. So thank you very much.